In the previous tutorial video, we developed two classes. So one is the point class, and the other one is the point tester class, which has a main method. In the point class, we actually got two attributes which characterize which point instance should be like with the x and y coordinate values over here. And you can see the attributes are simply just class level variables with a type. And also we define two versions of the constructors over here. As you remember, the name of the constructor must be the same as the name of the class. And also you can have a list of input parameters over here which are required to be passed with values when you try to call the constructor. In this case, you can see we got two parameters over here with double and double. And over here, you got two parameters here with character and double. So there's no ambiguity as to being confused about which version you're calling. So now we also develop some tester over here with the main method. And also we illustrated to you. Especially, I want you to really make sure you're comfortable with this particular illustration. Okay. What you really want to see, particularly, let me just give you very quick. Over here, you can see for this particular line, we explain how this can be translated into, how can be visualized into this particular memory object creation, and also storing the address of the variable. Let me emphasize again. Whenever you declare a variable of an object, whenever you declare a variable whose type is simply a class name, what you store in the variable is not the object contents themselves. No, it's not the case. What you store is just indirectly the starting address of that particular object in the memory. Okay, that's something you really want to keep in mind. Okay, it's going to be very important, especially when we talk about more advanced topics later in the course. Okay, so now for convenience, the way we draw and trace the object creation is simply by drawing a rectangle like this, and then with the title of the class name, and also with all the numeration of all the attributes over here, in this case x and y, and also the specific value for this particular object that's being created. And we're saying, since we're having an assignment over here to P1, that means P1 is storing this particular the address of this particular object. So that's why P1 is pointing to this particular object. It's a very quick recap from the previous tutorial video. Okay. So now, what we would like to do in this video is to continue with the tracing, but in a slightly faster speed, given that you understood at a lower level about the memory. But understanding the lower memory interpretation is really crucial as well, because otherwise it will be difficult for you to imagine why this particular shorthand for drawing, right? Okay, now I assume you actually review this particular part of the memory visualization carefully. So now, from now on, we're going to trace the object creation, use this notation over here. Okay. Now, I want you to just add a few lines to your code, just for the simplicity of the illustration, more clarity. So now, previously we created P1 with a calling version. Okay, basically we have two calls to version 1 of the constructor. One is 3 4, 3 minus 4. The other one is minus 2 minus 7. Can you add P2 creation, please? And also we got two calls to the second version of constructor, and then P3 and P4, and then one is with y and 8, which means we want to create along the y-axis, and for the second call we want to create along the x-axis. So we're going to trace 4 of them together. Okay, you can see eventually there will be 4 objects being created at the runtime. So 4 different regions in the memory to be allocated for the 4 objects, or 4 rectangles to be drawn. Okay, so that's something I want to show you. You want to be very comfortable and smooth in this tracing process before things get complicated. Okay, so now I'm just going to switch an iPad. I already got a snapshot for the 2 fragment of code over here. Again, you can see, let's be clear about the context before we start tracing. We have the point class over here, and also we have the point tester class, which got the main method. When we execute the code, we only execute point tester with the main method as Java application. And then we got these 4 lines of code to trace. Okay, each one of them is going to create a new object of type points. But for each P1, P2, P1, P2, P3, and P4, each one of them only stores the address of some point objects that we allocate in memory. Okay, and then each one of them is going to call a particular version, either version 1 or version 2 of the constructor over here, depending on what values you're passing. Okay, that's something we're going to see. Okay, let me undo this, and then let's go on to trace the program. Okay, up after here. Okay, so now let's do line by line. Okay, when I run the point tester as Java application, I'm gonna have the following. Okay, line number 1. Okay, let me just make it a little bit thinner. Okay, line number 1 over here. So we're gonna trace this code. Again, we're going to consider creating a new object over here in the memory first, and then we are calling version 1 of the point class. Why version 1? Because the first one is a number and the second one is also a number. Second version cannot be applicable because the first version, the first value is actually a character, right? So it cannot be applicable. So now what we're going to do is we're going to create an object over here. So I'm going to draw a rectangle box over here. Okay, an object over here. And since I'm calling this particular constructor, remember every constructor must have the same name as a class. That means I'm creating an object of type points. And for every points, it can be characterized, it must be characterized actually by x and y. So I'm gonna say points over here and then divide into 2 columns. So now the left column is going to be x and y. So these are the names of the attributes, right? So the x and y attributes are the same for every point object we're going to create. Okay, and then for this particular call, so we got 3 here and we got 3 here. So we're calling the first version of the constructor. You can think about this block of code for the first version can be used for more than one time. Every time when you're referring to this particular version, all you have to do as a user over here, for example, you're going to give specific value to be used in order to replace new x and new y. Okay, so now in this particular case, new x is going to be 3. Okay, so now let me just be a little bit more precise for you. So 3 is going to replace new x over here, and minus 4 is going to replace new y. Okay, let me just do the replacement quickly. So that means every occurrence of new x is going to be replaced by 3. Okay, new x is going to be 3, and also every occurrence of y is going to be replaced by minus 4. So new y will be minus 4, and new y will be minus 4. So that means we're going to say x is going to be assigned to 3. So x is over here, okay, x is going to be assigned to 3, and also y is over here, is going to be assigned to minus 4. Okay, it's going to be assigned to minus 4 over here, y. Okay, this is the first call. So we're creating this object, and then we are declaring a variable called p1 of type points, which means p1 can store the address of some point objects only. And now, because we're going to assign the address for this particular newly created object of points with 3 and minus 4 into this particular p1. So p1 is going to store the address for this particular object. So the way we draw it, we say p1 indirectly points to the points. If you want to know what is the objects being pointed to by p1, you have to look at the store address in p1. Okay, that's something I'll show you in the debugger in just a moment. Okay, p1 over here. And then, so this is the first line. Okay, what about second line? Okay, for the second line, it's going to be following the same way. Okay, so for second line, let's use green over here. So now for the left, for the right hand side, for the new keyword over here, again, we are trying to call the constructor from the point class, right? And then this will also be the first version because we got number and also number. Okay, so what we will do is we're simply going to draw a rectangle box representing objects again because it's point, so it's going to be of type points. And then every point has x and y. So we actually draw the same. Okay, x and y. You can see x and y and also x and y. But the values for the attributes might be different. Okay, so now you can see. So now this time, this is now the second time we are trying to call the same block of code. But the new x and new y will be replaced by different input values specifically, right? So now you can see new x is going to be replaced by minus 2. Okay, so I'm just going to put minus 2 over here. And new y is going to be replaced by minus 7. Okay, I'm going to replace that by minus 7 here. More precisely, every occurrence of new x is going to be replaced by minus 2 for the second call. And every occurrence of new y is going to be replaced by minus 7 for the second call. Which means we're going to do x is assigned to minus 2. Okay, x over here is going to be assigned to minus 2 for this particular object, right? For this particular call. And y is going to be assigned to minus 7 over here. And then we're going to declare a second variable called p2. and P2 is only going to store the address of some object. In this case, this newly created objects, I'm going to assign to it. Okay, so P2 indirectly points to these objects. So after the first two lines, blue and green, so we have created basically two objects of type points. Both of them got X and Y, and also both of them store their addresses into P1 and P2 respectively. Okay, so that's after the first two lines. Okay, so now let's have a look at the next two lines, and that'll be a little bit more interesting to see. We're still going to create the point objects, and the layout for the point object will just be the same, only X and Y. However, we're going to execute different blocks of code. That's actually going to be the difference. Okay, so now let's see this. Let me use pink for the first one. Let's say we go ahead to execute the third line over here. So we're going to execute the right hand side over here, new points, and then we're going to pass character Y is a character literal, and also 8. So this cannot be first version anymore because Y character over here does not match the first variable type, right? So double does not match with the character, so it cannot be the first version. On the other hand, the second version over here is a character, so that's okay. So now what we want to do is over here, if you say new points and then Y, so now we're just going to first, because we are calling the constructor from the point class, again we're going to look at the template over here. Every point object is going to be characterized by X and Y. Okay, we're going to draw the same box over here. Okay, so I'm going to draw the pink over here is going to be of the same type, points, and then we also have X and Y being the attributes. You can see X and Y over here. And then what about the values for the attributes to be initialized? So now which version of the constructor are we calling? As we explained, we're going to calling this particular version of the constructor over here the first time. And then Y is going to replace the first input value axis over here. So axis is going to be replaced by Y. Moreover, every occurrence of axis is going to be replaced by Y. So axis over here will be replaced by Y as well. Okay, and then what about the second value? Second value is simply 8 over here. That means we're going to replace every occurrence of distance by 8. Okay, also distance over here by 8, and also distance over here by 8. So that's exactly what we're going to execute. So now if you consider this block of code, exactly what's going to happen. You can see when we try to execute this if branch, if you recall how we trace the if statements from the previous videos. Okay, so now literal Y equals literal X is false, which means we're going to bypass this particular branch over here, and then we're going to go to the default case, which is the else branch. In this case, we're going to assign basically X to be 0 and Y to be 8. That's what we're going to do, right? That's basically the points along the y-axis. Okay, it's going to be X is assigned to 0, and also Y is assigned to 8. Exactly what we just say over here, right? Okay, that's the first call. And then we're going to declare on the left-hand side a variable called P3. So P3 over here again is just a variable that's going to store the address of the new objects over here by the assignments here. Okay. Okay, let me just circle more nicely over here. So P3 is now going to point to this particular object. Okay, so now let's try to see the last line over here. If you look at the last line, let me use orange over here. The last line is basically calling another constructor from the point class, right? Which version is that? You can see the first argument over here, the first input value here is character X. Again, it's going to match the character for the second version over here. So that means we're calling the this same block of code for the second time. Okay, and then we're going to now replace the axis over here by the character literal X. Okay, I'm just going to put X over here, X, and then we're going to moreover, every occurrence of axis will be replaced by X. So that means axis over here is going to be replaced by X. Just notice the color. Just notice on the orange side. Okay, and also the second value we are passing is -5. That means every occurrence of distance is going to be replaced by -5. -5 over here, and also every occurrence of distance will be replaced by -5, and this occurrence here also replaced by -5. Okay, so now if you look at that, let's try to evaluate this block of code for the second time. Okay, if you look at that, if x equals x, the literal is going to be true. So that means we're going to execute this block of code over here, whereas in the previous first call, we're going to bypass this branch, right? It's either y versus x. So now that means we're going to execute this block of code, whereas we're going to bypass this particular one for the second call, right? So now we're going to say x is assigned to 8. Okay. Oh, I forgot to draw the box. Basically, the box over here for the orange, we're just going to have a point object over here because we're calling the point constructor over here. And for every point, we got x and y. Okay, again, x and y. And we're going to assign, in this particular case, right, as we said, x is going to be assigned to 8. And also y is going to be assigned to 0. And then when we do the assignments, so when we do declaration, P4 is declaring to be a variable that's going to store address only for the point objects. And then when we do the assignment, we're going to make sure P4 store the address for this particular object. So it's indirect. So now we got P1, P2, P3, P4. Okay, why is this object oriented? If you think a little bit more carefully, basically what we have done is this. Think about this is the two-dimensional plane that we are familiar with, x and y. What happens to P1? P1 actually got 3 and minus 4. So P1 is exactly here, 3 and minus 4. Okay, and also what about P2? P2 is minus 2, minus 7. Okay, P2 over here is minus 2, minus 7, right? And then what's P3? P3 is 0 and 8, along the y-axis, 0 and 8. So this is P3. So we got 0 and 8 over here. And also we got orange, which is 8 and 0. Okay, in this case, there was only one thing I did wrong. Okay, so actually you can see that over here for P4, the value over here should be minus 5. Okay, actually I just copied the wrong value. Beg your pardon. Okay, so what really I meant to say, well, sorry, that's too big. So really what I meant to put over here is simply just minus 5. Okay, minus 5 over here. So what about orange P4? P4 would be minus 5 and 0. Minus 5, a little bit to the scale. So P4 is simply minus 5 and 0. Okay, you can think about what happens over here is the reality over here. And then at the runtime, we are trying to create objects over here. At the runtime, we are simply trying to create objects over here that represent the reality, right? You can see the one I'm trying to highlight in pink. So these are the 4 objects we create at the runtime, which will correspond to the 4 points that we can visualize in the two-dimensional plane in reality. Okay, so that's kind of the why the object-oriented programming is so. Once you understand it, it's actually quite intuitive. You really have a very straightforward way to map things to phenomenon in real life. Okay, so that's about the 4 objects over here. So hopefully you're comfortable with it. So you want to make sure whenever you're creating a new object, how you can trace it. Especially when you see the new keyword over here, you want to know which class is being called. So you will know which how to draw the box. In this case, you can see all the boxes are of type points over here. So all of them are of type points. And also for all of them, they also each box actually got exactly x and y, x and y, x and y, and xy, simply because the corresponding class has just x and y. Okay. However, you can see that for each of the objects over here, the value, for example, over here you can see the x value could be different. For P1 is actually 3. It can be 0 for P3, minus 2 for P2, and minus 5 for P4, which means even though P1, P2, P3, and P4, each one of them has an x value. However, the x value might be different. Okay, hopefully you see the difference over here. Okay, that's about tracing these on the iPad. I would like to show you very quickly how you can trace them in the Eclipse very quickly by using debugger. And then I want to show you one more thing. Two more things actually before we end the video. Okay, let's show the debugger quickly first. I want to show you exactly how you can see this kind of particular visualization in the Eclipse. Okay, so now I want to actually do one more thing over here. So system.out.println over here. If I simply say P1 over here, P2, P3, and also P4. What does it really mean when I simply say I want to print out P1, P2, P3, and P4? Okay, I want to trace. Let me see the result first, and then we will actually tell you why. Okay, to really help you anticipate what the answer should be is very easy. I have a simple question for you to answer. If I simply say integer x is assigned to 5, and then I say system.out.println, and I simply say x, what will be the value being printed out? We know very well it should be 5 because 5 is actually stored into x, right? So now, if you want to know what exactly is going to be printed out in P1, P2, and P3, and P4, think about what P1, P2, P3, and P4 are storing. As I emphasized for so many times, whenever you declare a variable whose type is actually simply a class name, that means you're storing not the entire objects into the variable. You only store the address of the object in the variable. So that means we can anticipate when we try to print out the value that is stored in P1, we will see some kind of address. And also when we print out P2, it's also going to be kind of like an address. However, P1 and P2, since they are using different new notation, two separate new expressions to create. So that means P1 and P2, they are simply distinct objects, which means the P1 and P2, even though they are both storing addresses of point objects, but the addresses between P1 and P2 will simply be different. Okay, that's something I will illustrate to you. Now let's just see exactly how it is going to be in the point tester. Okay, so let me run it as, let me say run as Java application over here. You will simply see, oh, you can see, right? So this is so-called a pseudo address. Okay. Sorry, let me write it out. Prints out pseudo address, which means it's not exactly the memory address in the binary formats, but just kind of like an address notation. Okay, prints out pseudo address over here. Okay, well you don't have to know exactly what the values really mean. All you have to know is the address for P1 over here is different from the address for P2, which is also different from the address for P3, which is also different from the address of P4. So which means we have created four distinct objects. That's what you have to know. Okay. So now to make it more precise, okay, what I can do is this. I can say system.out.println. For example, I can say P1 and P2 store different addresses. Okay, I can say, for example, P1 is not equal to P2. If I just want to compare the values of the address, I can say P1 is not equal to P2, right? That just give you one example. You can also do between P1 and P3, P1 and P4, and etc. Okay, so now if I try to execute it, I would say P1 and P2 store different addresses. That is true, because P1 not equal to P2 will just give you true. Okay. On the other hand, well, let me just play a little bit with the logic. If I say P1 and P2 store the same address, I want to know if that's true or false. Same address. In this case, I can say P1 equals P2. In this case, of course, it's going to give me false, right? You can see these two values. So this value equals this value would just be false. Okay, if I just do it, you can see these two are not. They are simply consistent with each other. They are not contradictory. Okay, so they are the same. Okay, so now I want to do a little bit debugging for you. Okay, to actually see what's going on over here. Okay, so what I would like to do is let me just put exactly over here the line. Let me say line number 9. Okay, let's see exactly how things will be executed I want to show you just the object structure that you can see from the debugger. It's really important to see. Okay, what I would do is I will right click on point tester, and then I would say debug as Java application. Okay, and then switch to the debugging perspective, and now I want to go to variables over here. So now I'm pausing at line number 9 before I try to create P1. Okay, so now if I say step over here, I'm going to get P1 over here, right? You can see some information over here. If I just click on P1, it's going to show me the P1's address over here, okay? And also if you expand the P1 over here, you can see that's corresponding to exactly the X and Y I put in the box, all right? You can see point is the type of the object, X and Y are the attributes for the corresponding class, the corresponding template. What about X value? X value, okay, over here you can see if you click on X, it's simply 3.0. For Y, it's minus 4.0. Okay, 3.0 versus minus 4.0. Okay, what about when I say create P2? The same. If I say step over, I have just another object P2. You can see their address is simply different. How can I know? If you go to expressions, okay, let me just delete the previous one. Okay, I can simply say right click and then remove all, so we don't get distracted. Okay, so now I got P1. You can see P1 is of this address over here, and also we have P2 over here. In case you don't see the expressions panel, you can just go to Window and Show View, and you can go to expressions over here, or you can see from others. Okay, and now I want to know whether P1 and P2 are the same addresses. If I say P1 equals P2, it simply tells me false, right? Because they are different addresses. They store different addresses of different objects. And then I can say P1 not equal to P2, right? Because they are different addresses, so of course, when you say P1 and P2 are not the same, it will be true. Okay, so these two expressions are completely equivalent to each other. So now what we can do is, so now we got P1, P2, and let's create P3. Let's go back to variables over here. So P3 is actually created by calling the second version of the constructor, which we just traced. So now if I say step over, so now we also got P3, which is also of type points over here, and also it has a different address. Okay, if you expand P3, it's also got X and Y with 0.0 and 8.0, right? 0.0 and 8.0 here. Okay, and one more, if I say step over again, we're going to get P4 over here, also got a different address for the points. You can see the convention in Eclipse for the pseudo address. It's going to start with the type of the objects first, which is point, and then with some notation at, and then with some unique identifier for the address. Okay, that's something you want to know. Okay, and then we got P1, P2, P3, and P4. So now, since we got all the 4 objects created together, I want to illustrate one more thing to you. If you expand all the objects over here, P1, P2, P3, and P4, okay? So several things to know. P1 has an address, P2 has a different address, P3 has another different address, P4 has yet another address. However, all of them are the addresses of the same type, which is point. That is why for each P1, P2, and P3, and P4, the objects they are pointing to has X, Y, also has X and Y over here, also has X and Y over here, also has X and Y over here. However, the X and Y values for P1, for example here, you can say P1, the X value for P1 is actually 3.0. The X value for P2 is actually minus 2.0, and the X value for P3 is actually 0.0, and etc., right? So that, again, is really something you want to get very clear. For every object of the same type, in this case, P1, P2, P3, and P4, they are objects of the same type, which is point. All of them got X and Y, X and Y, X and Y, X and Y. However, the specific values for the attributes for each object may be different. That simply corresponds to real life, right? Even though you got so many points in a two-dimensional point, each one of them may or may not have the same X or Y coordinates. Okay, so you can see the combination of the X and Y value over here. Okay, hopefully you can see the point over here. So that's how you use the debugger to trace the creation of the objects. Okay, so I'm going to just stop over here. Okay, and then I'll go back to Java perspective over here. So what you really want to get used to is we can print out the address for each object. Okay, after creating, basically every time when you use the new keyword, it's going to create a uniquely new objects every time. Okay, that's why P1 and P2 they got different addresses. Okay, so now I got one more thing to actually show you, which is a common error which you want to avoid before we end the video. Okay, I want you to revisit this particular second version of the constructor for the point. Remember we said before over here, we actually, if you want to call the second version of the constructor, you have to pass the first input value being a character, and the second value over here being a double value, right? Could be any value with any numerical value with a fractional point. Okay, so now I want to know, okay, as far as the, so now we want to make sure you always write code that can compile. So as far as a compiler is concerned, this is how they can view these methods. And then I'm going to suggest some potential new constructor version. We want to judge on the paper first whether that should be allowed or not, and then we'll see in the Eclipse. Okay, so now let me just go back there. Let me start with a new page. Okay, so now we talk about different versions of the constructor. Okay, so now let me write it down. So now we got versions of constructors. Okay, so now we want to know so now let's think about what we have got already. Okay, well, we have got version number 1. We simply got the same name as a class points, and then we have double. Okay, you can review your code to actually make sure I'm doing the right thing. Okay, the right decoration. So we simply say new x, comma, double, also new y over here. That's the first version. And also we have points over here, and then we also got character axis, and also we have double over here, which is distance. Okay, so these are the two versions. The reason that it does not cause any problem as far as the compiler is concerned, let me tell you something over here. The name of the variables is not so important as long as the variables over here somehow does not clash with any existing variables that you declare. But that's something usually you can be very easy to find out. Okay, so now what I want to say is, as far as the compiler is concerned, this is how they interpret this particular constructor. Okay, it's not really valid syntax, just a conceptual idea. Okay, so now the first version is going to take a double followed by another double. So the name of the variable, the name of the input parameter is not important to the compiler to decide whether your code should compile or not. Okay, what about the second version? The second version over there is just going to be another constructor over there. The first input is going to be of type character, followed by the second one being of type double. You can see over here, as long as the list of parameters can be distinguished from one to another, you don't have any compile error. You can see double over here, it can be distinguishable from the character over here, even though you have 2 and also 2. That's okay, as long as the first one is different. So that means if you are passing the first argument, you're passing the first input value being character, you know you're calling the second version. If the first input is about just a double, that means you're calling the first version. Okay, that's what we have got so far. Now, I do have a question for you. Let's say I want to somehow create another 2 versions of the constructor. Let's say over here, I know that this second version here simply just tells me what the axis is, which can be x or y character, and also tell me what the distance is. This distance is from the x or y axis. So now I want to create the following. What if I say the points over here? Let's say the third version I want to create is I want to do specifically for the points along the y-axis. Let's say if I want to create a point along the y-axis, I know that I should only just specify the distance from the x-axis, right? So what about I simply say double over here, distance from x. axis. Okay, it's just a variable name over here. So just one input parameter of type double. Okay, on the other hand, symmetrically, I want to create version number 4 over here, points, and then I want to create, let's say, another point over here along the x-axis, which means I'm going to specify the distance from the y. Distance from the y-axis. So I would say double over here, and then I would say distance. Remember, the variable name should really be lowercase for the first compound word and capitalized for all the later words. Distance from y-axis. So now, would it compile? Of course, I can define something over here accordingly. But now, as far as the compilation is concerned, are these two versions going to compile? Okay? I have a hint for you before you answer. Think about how the compiler interprets the input parameter types for the constructor. Okay? If you do that, you will know that, as I said before, even though we have different names for the parameter, one is for x and the other one is for y. However, the names are not relevant to how the compiler decides whether your constructor should compile or not. What's really important is the type over here. So basically, think it this way. How do I use it? If I try to say points over here, if I simply say, new points and then 3.4. So now if I simply say this in the tester code, 3.4, which can match either this or that, but which version am I talking about? In this case, it is ambiguous for the compiler to decide which version you're trying to select to call for the constructor, right? So now it can be either this version over here or this version here. It's just confusing to the compiler. So as far as the compiler is concerned, for this particular version number 3, it's simply just point with just a double. And for this version number 4, similarly, it's also the point with the type double. You can see over here, between the two parameter lists, double and double, they simply clash. It's just ambiguous. So when you got 3.4, you simply don't know which version is being called. So that means we cannot compile these two versions that we're trying to add in. Okay, that's a very common mistake you want to avoid. Whenever you try to call this particular version of the constructor, you want to make sure, well, two issues over here. When you try to define methods or constructor, you want to make sure the list, if the method have the same name, for example, let's say the constructor, they have the same name as a class name. You want to make sure the list of parameters can be distinguished on their types or the size, so that when you try to call them in the tester, you can actually the compiler will actually know which version to choose for you. Let's double check that this is really a compile time error and make sure you don't really make that mistake. If you go there, and now if I simply try this, okay, I can simply say, for example, version number 3, I can say points, double, I would say distance from x-axis. Okay, I do something over here. So far, so good. So far, you can see a single double does not clash with character double, does not clash with double and double. So far, it's okay. But now, as soon as I try to add in another version over here, point, and then I say double. Okay, let me just get rid of the space over here. Point double, distance from y-axis. As soon as I say that, you can see things stop to compile for exactly the reason I just explained. Let's see exactly what the error message is. Again, every time if you got error messages from the Eclipse, I encourage you to at least read in the message. They might give you some information that's useful. If you just go there, move your mouse over, it says duplicate method for point double. Look exactly the point double over here. You can see this part, right? That's point double. Versus the point double over here, you can see for the second one. That's exactly what I tell you before. What I told you before was, this is how the compiler is interpreting the version number 3. Point constructor followed by is going to expecting a double input. Versus point number 4 is also a point constructor, which is also expecting a double value only. So that means these two are simply confusing to the compiler. You simply don't know when you try to simply call points with 3.4. You don't know whether this version should be called or this version should be called. So that's an error. It's a confusion to the compiler. Okay, so now I want to really add in these two versions over here just to let you know, whenever you want to define constructor or later on methods, you should not try to cause any confusion to the compiler. That's the #1 mistake you can make. And the names of the parameters is not a source of error over here. It's mainly the types over here. Okay, double versus double, which are the same to the compiler. Okay, so now what I will do is I'm going to select these two versions over here, Control / put it into comment so the error can go away. Let me write a comment for you and then we're done. Okay, and then I would say adding these two versions of constructors will give a compile time error because from the compiler's point of view, one is expecting, okay, how about this? Both are expecting a single double value. So when you call points, let's say 3.4, it is confusing as to which version to call. Hence the compile time. Okay, hopefully that's clear to you. I want you to really understand this very well and apply that to later when you define new constructor or new methods. Okay, so that's about it I want to talk about in this video. And later on, in the next video, we're gonna give you some improvement to defining the constructor.